Good morning, good afternoon, good evening, wherever you might be. Thank you so much for joining us. Today we have a great webinar by the amazing MVP Regional Director, Reza Rad. He's going to talk to us about time intelligence calculations. It's going to be super exciting. Let's go on to the next slide here. And there we go. Reza is a MVP Regional Director. He is a consultant, a trainer, and his company is Radicad. They're amazing. You should go check them out online. And to give you more details about how amazing Reza is, we'll throw it over to him. He's got a great slide to show you about that.
Great. Thank you, Kelly.
No worries.
Really appreciate the time. And thank you, everyone, for joining and watching this live now, or those of you who will be watching this later from the YouTube channel. By the way, these would be recorded and shared through Power BI YouTube channel, so make sure you go and subscribe there and watch this webinar and many other webinars and videos which is available over there. Okay, so I'm Reza Rad. I'm based in New Zealand, Auckland, New Zealand. I'm a Microsoft Regional Director and MVP. I've written some books on Power BI. I do training and consulting on Power BI a lot, and I'm writing blogs and speaking in webinars and conferences. My contact information is all down in this slide. Feel free to reach out to me. I do also have like some videos in Radicad YouTube channel, so feel free to go and check them out. They're all free, available for you to watch and learn. Okay, this session is about time intelligence with Power BI, and mostly in my presentation I do a lot of demos. So we'll jump right into some demos. So when we talk about time intelligence in Power BI, there is a big concept of like having a date table. Let's say I have a Power BI solution like this. I have a sales table. This is the only table that you can see right now in my report, in my model. One table, it has some columns in it, which I can go and start slicing and dicing. You see that some of these columns are date columns. And when you see they are date columns, you see that they are like marked with a little calendar icon, and I can expand them and see like a date hierarchy under those. Like, for example, under this, right? Why this is happening? This is happening because Power BI behind the scene is creating another date table under each of these date fields. You see here I have like 3. That means Power BI behind the scene created 3 other date tables connected to these 3 fields. So in fact, I have 4 tables, but you don't see that. You just see like 1 table, and the thing is running very smoothly. Like if I want to slice and dice something here, let's say, I don't know, sales amount by order date, I can just drag the order date itself. And behind the scene, it is using the hierarchy that is coming from the date table underneath, and it works perfectly fine, right? This is what we call as the default date table in Power BI, and the reason that that exists is that there is an option in Power BI, options and settings options. There's an option here under data load called O2 time intelligence, which is by default on. When you have it on, this means that Power BI will go and create those date tables behind the scene, which can be handy, as you can see here. Without needing any tables, I managed to slice and dice things by my date fields. However, sometimes I need some, let's say, extra features more than the default configurations, which can't be available in this. For example, I might need my date table to have also, like my date hierarchy, to have also a week level in it. I might need to have like fiscal columns, fiscal year, fiscal quarter, fiscal period. I might need to bring public holidays in it. I might need to combine it with specific calendar days that I have in my organization and things like that. In those scenarios, we go ahead with not using the default date table. We go ahead with adding our own version of the date table. So this is like the default date table. Another option would be going and adding our own version of date table. So this is another solution. You see it is still like the same file, but what I'm going to do in this case is that I'm going to add my own custom date table, and there are different ways you can create that. You can write a DAX expression to create a custom date table. I have a Power Query statement. I'll just show it to you here. This full statement will give you, full expression will give you a date table with everything that you need, with fiscal columns, everything you need, and it's configurable. You can download it from my blog article about that. The full code is available there. I can use that and create a date table just like this. Start blank query, and then in advanced editor, I just paste it here. I do some configuration. I can say, OK, this is today, start this because my data is pretty old. So I say started from 2005, for example, ends it at 2010, right? I can define it and I can say what is the start of fiscal year. Here it's like 7, so July. You can configure any of these. I click on OK, and that creates the date table. I'm going to call this date table, close and apply. Now this table comes into my model. Here it is. And I can create a relationship with that. So that would be like something like this based on whatever date field I have. So here it is like that, right? So that would create a relationship. However, if I do this, also, I am using my custom date table, but Power BI is not aware that this is a date table. So what it is going to do is that it is going to create other date fields, other date tables under this date table. You see that for every single date field that I have within my date table, Power BI created another date table under this, which can be quite a bit of like extra things. We don't really need that. So what you can do in these scenarios, as I mentioned before, you should go to options and settings. You should go here and turn off the auto date time. By the way, if you want to do it for all files you build in Power BI Desktop, you can do it in global settings. I'm doing it just for this file, so I'll do it like that. So when I turn it off, you see that all of those are gone now, right? Here you see that now Power BI doesn't really go and create a date table. But it also means that if I build a visualization like this, like sales amount here, sales amount by the date, this time it doesn't really bring the, I need to have something like this. It doesn't bring the hierarchy. I think I went to the wrong visualization. So here, this visualization, and let's bring this to the value. OK, so it doesn't show me the hierarchy, as you can see here. It just shows me the actual date. How can I switch it to hierarchy? Because there is no default date table, there is no default hierarchy. I should go and create my own hierarchy. So I can start by like having year as a hierarchy. So I can build a hierarchy like this. Then I can add month under that. So that would be like month name under this, and then day itself. So I can build the hierarchy the way that I want, and I can call it calendar hierarchy. This is not a session about a video about hierarchy, so I'm just going through that very fast. Then I remove this. I'll bring that hierarchy over here, which gives me the ability to move into hierarchy. But then you have to do the sorting and things like that yourself and configuration of that yourself. So as you can see, if I have my own custom date table, it looks like that. And another thing that you've seen here is that when you have your own custom date table, everything should be customized. Here you can see that the order of the month is not correct. August, December, July, November. This is like alphabetical order because this is everything custom, a custom date table. So I need to go to like this date table, find that month name and say sort this one by the month number. That would help me to get the right sorting. Right now you can see that it is sorted correctly. So what I'm showing to you so far is nothing about time intelligence functions so far. I'm talking about the basis of that. So the basis of that is that you either go with the default date table, which means you just need your date field, you bring it into your visualization, you see the result, or you need your custom date table, which is like this one. And if you do that, you need to build your own hierarchies. You might need to do some configurations like that. What is the pros and cons so far? Like if you use default date table, much easier to use. You just drag and drop and use it. If you use custom date table, you have the ability to make it flexible, to bring fiscal columns, to bring public holidays, to bring anything else that you want. So like pros and cons, but what matters here is that when you write your time intelligence calculation, the way that you write it is different based on which method you use. So I'm going to show you like a couple of these. Let's say I want to do year-to-date calculation. I show only this example in these two, then I moved on, then I will do the rest only in one because I want just to show you what is the difference. Then the rest I will do only in one. Let's say I want to do a year-to-date calculation. Now, in Power BI, when it comes to calculation, you write DAX statements, and DAX statements can be written as a measure, which acts really powerful because that way then you'll have a dynamic calculation in your Power BI report. So what I can do is I can create a new measure. Measures in Power BI are dynamic calculations. I'm going to call this sales. Let's start with just normal sales. So sales would be sum of the sales amount. So this so far is not a year to date or anything like that. It is just sum of the sales amount, right? I start with this measure because then I want to use it in the year to date, right? So that's my sales measure and it comes over here. Now this means that if I change this to a table, let's do that for a second. And instead of this, if I bring the sales, this shows me the sales value, right? So now I'll do another measure here. And in this measure, I say, OK, this measure is going to be sales year to date. Now, when it comes to calculations related to dates and time, we have a set of functions in DAX, which we call them time intelligence functions. These functions are helpful in getting any insight from a date and time field. For example, year to date is one of those. If I want to calculate year to date, there are different ways to do that. One of the ways is this. I can say total year to date. Total year to date is a function that calculates an expression based on a filter and based on a date filter and gives me the year to date for that. So I can say my expression is sales itself, saying that calculate sales. And then here dates, whenever you see dates with an S, that means it is looking for a column, a date column. This is the column that is part of a date table. Now, in our case, because here we have only one table, we have sales table, we don't have any other date tables. Our date column is order date, right? So I'm going to type order date. However, because I'm using the default date table, this column is not really a column. This column is connected to another table behind the scene, the table that you don't see, that built-in default date table. And these are columns of that date table. So whenever I type that column name, it comes with this. In my courses, a lot of time I get questions that why is this coming? What this means? This is exactly meaning that this, in fact, this whole thing, the order date, is not a column. Imagine that as a table. From that table, you have these columns to pick from. And because in this parameter, we need a date field, and the first one is the only date field. The others are other fields. So I'm going to select that. So this dot date is only needed because I'm using the default date table. This is not a date field. It is like a date table, and I'm getting the date column out of it. I need that if I'm using the default date table, right? So altogether, total year to date of this measure for this date column, and I'm going to add this in my table, and you can see that this is year to date. What year to date is? Year to date is that means that for any given date, let's say 5th of July, this value is not the value of the sales for that day only. It is the value of the sales from the beginning of the year, calendar year in our case, 1st of January all the way to this year. But because our sales started from 1st of July, so this would be like sum up of all of these values until there. Or 6th of July, that would be adding all of this, something like a running total. However, the running total will just continue even after the year finish, when this next year starts. Year to date doesn't. I can remove the day from here, and then you'll see how it works. So here you can see that it is accumulating values all the way to here, which is end of the year, which is December, and then it starts again from January. Right, accumulating. That's how year-to-date calculation works. Very simple expression here. The only trick here is to use that dot date, and already you know why you should do that, right? Now this is when I use default date table, but what if I don't use default date table? This is the other scenario. This is the scenario that I have my own custom date table. Let me show you the model. I have my own custom date table. So if I want to do something like that here, now let me also change this to a table visual. Okay, so table visual, and just to make this very similar to the other one, I'll start with that measure of sales again. So I'm calling this sales, and this would be sum of the sales amount. Right, bringing that over here instead of this field. And now I'm writing my year to date calculation. The difference here is that the function itself is exactly the same. So I can say give me total year to date of the sales. So far is exactly the same. Now I need my date field. Now my date field from this table is connected to the date field from the other table. I should pick the date field from my date table. This should be the date field that doesn't have any gaps in it. If I use the order date in the sales table, that will give me incorrect result because I might have some gaps. For example, 1st of January, there might not be a sales. In Christmas Day, there might not be a sales. So I will be using this one, the date table that has all the days with no gaps. And that means the full, the date field inside here. Now, when I use that, you see that there is no dot date or anything like that. This is a difference, right? I don't have any of those, and I don't really need that because this is my date table already, and the date is a column under that. There is no another date table under that, right? So only this expression, only the date field itself, and this will give me exactly the same result. This is my measure. And just to make it a little bit bigger, you can see that it is exactly the same thing. Now I'll remove the day from here to give you exactly the same output as well. So here it is. You see that it is accumulating for these, then the rest and then the next year. So exactly the same result. The reason I showed you this in both ways is that I have seen Power BI models using both of these methods. Many examples that are using a default date table like this, many examples that are using a custom date table like this. Pros and cons on each, like which one you go for your solution. However, both methods would work with time intelligence expression. The only difference is that in the default expression, you should remember to add that .date under in your expression, like this one, for the default one. For the normal one, no, you don't need that. Okay, so I'll be continuing this on my custom date table moving forward. So we have created the year to date. Now let me add a couple of more calculations into here. What if I want to calculate quarter to date? That would be also very simple to do. I can do a new measure, sales quarter to date. Similar to total year to date, we also have total quarter to date, right? Very simple expression to use, which would be, again, give me the sales based on the date field. Right, and the difference is that because this is quarter to date, it just restarts at the beginning of every quarter. Let me make this grid a little bit bigger. Yeah, here it is. So you can see that the quarter year to date is also accumulating, but it's restarting at the beginning of every quarter compared to year to date, which is going all the way to the end of the year. Right, similar to this, we also have month to date, which in this view would be the same as the monthly sales itself. If I have day, then I'll see it is incrementing. Now, in a lot of scenarios, you also need to calculate this fiscal, like what is your fiscal year to date, fiscal quarter to date sales and things like that. There are two ways to do that. One way is that if you have your own custom date table with fiscal columns like this, then easy enough, you can actually build, you can actually use those columns, your fiscal year, your fiscal month and things like that here, and everything would work perfectly fine, right? However, let's say, what if you don't, right? Let's say you want to calculate this regardless if you have the year or fiscal year here. You want to calculate fiscal year to date regardless of that. Then you can do this calculation like this. There is a parameter in total year to date function that you can customize it. I can say this is sales YTD fiscal. Now that total year to date function that we have used, as you can see here, it has two mandatory parameters. In DAX, these are mandatory parameters. Anything that is inside square brackets, these are optional parameters. And one of these optional parameters is year and date. When you don't specify this parameter, the default value is used, and the default value is 31st of December of any given year, right? That means a calendar year to date. Now, if you want to use this to become fiscal year to date, then this should be your end of fiscal year, the date that your fiscal year ends. You can do it with something like that. So total year to date of the sales measure. Date field, I need these. These are the first two parameters. As you can see, I can just skip filter and do the next one right over here. So my year and date, there are different ways you can pass it. You can do something like this. This means 30th of June. You don't need year here. You just need the month and the day. And there are different formats working. You can say 06-30, 30/6, depends on the locale of your system. Different configuration might work. You can even write June, GUN, and things like that, right? So if I do that, this considers 30th of June as end of my fiscal year and restart actually accumulation after that. So let me show you how this works here. So here it is. You can see that this is also accumulating, but you can see the difference right over here that this is accumulating. It is not stopping at December. The normal year to date restarts at December, but this is not. This is still continuing, and this is restarting over here at July, which is where my fiscal year starts, right? This is now year to date fiscal. This is normal calendar year to date, right? So one easy way to do that is just to pass that fiscal year start over here, right? Okay, now year to date, quarter to date, and things like that. These are simple functions that you use with just knowing the function, like total year to date. There are, however, other calculations in the time intelligence world that needs a little bit different behavior to get the right result. One of those is calculating the sales of the same period, but last year. For example, if I'm looking at September 2006, I want to know this sales of September 2006, which is $350,000, whatever, 466.99. I want to compare this with September 2005. I want to see the growth year over year. This is one of the most common calculations you have in many scenarios. You want to compare this period with the same period last year and calculate the growth if there is any, and even get the percentage of that, right? How you can do that? You can use another time intelligence function for that. Let me create another measure. This one, I'm going to call it sales same period last year. By the way, when you have too many measures, this is starting to grow, then it's a good idea to create like a measure table and put all your measures over there. However, this is also a practice to keep all of your measures in the related table. In this case, because everything is related to this table, I'm going to keep it here. So same period last year, sales, I want to calculate it. Now, there is a function actually for that. There is a function called same period last year. So very easy, very simple to use. Same period last year function accepts a column as an input. Remember, whenever it is dates with an S, it is looking for a column. When it is date without S, it is looking for one single day. So what is a column that I need to provide here as an input? The date column that is part of our filter context, which is the date column from the date table, right? However, if I use this expression itself, is not going to be the final result, because same period last year is not returning one single result. Here you can see that same period last year returns a set of dates. It means it returns multiple values. If ever I use this expression, the expression works fine, but as soon as I add it to the table, I'm going to get an error, right? And an error is saying the same thing, right? This returns multiple values where we expect one. Your measure should be returning one single value. So what is the problem? This is returning a date table. This is returning a table. This is not returning one single object. This table is the table that tells me what is the same period last year. For example, if I'm in April 2007, this is giving me April 2006. Now I want to use that to calculate the sales of that period. So this would act like a filter for me, right? I want to say, give me the sales in this period based on some calculation, right? And there are different ways you can do that in DAX. One of the most common ways of doing these calculations in DAX is the calculate function. Calculate is one of the most commonly used functions in DAX, specifically because it is so generic to use. Here you can see that calculate accepts an expression and a bunch of filters. So if I want to say, give me some of the sales for the same period last year, I can use that. This expression would be sum of sales, and the filter would be same period last year, right? So I can do that. So my expression is the sales measure itself, and the filter, I don't need to write something like filter. This would be my filter, right? Same period last year, because for any given date, this would be the same period last year of that. For April 2007, this would be April 2006, right? So this simple expression will give me that result. You don't really need to go and find what is the date last year and find it and filter the data based on that. This function does everything for you, right? So after doing this, now you can see the calculation works just perfectly fine. For some of these, it's blank, like March 2006. The reason is that there is no March 2005. The sales started from July 2005. So that means that the first month that we would have the same period last year for that would be July 2006. So July 2006, this value is actually the same value that we have in July 2005. You can see it over here. Or in August or in September. This is the September last year. So now what is the point? The point is that now that I have these from the last year, beside these from this year, I can compare these two, get the variation and calculate the percentage easily, right? So that would be a measure like this, and that doesn't need to use any specific function. I can say sales year-over-year variance. That basically would be the sales this year, which is sales, minus sales same period last year. You can use other measures in inside the definition of a new measure, and you see them defined like this, right? This would be what you can call it as growth or something like that. I call it variance, right? So here, for example, you see that in July 2006, this year's sales is $500,000. Last year's sales was $473,000. So it's like $26,000 increase. However, for September, it was decrease. You also see something else here, that for those periods that I didn't have the last year, it is giving me actually like a incorrect result, right? Because there was no last year, this is the variance. Now you might say this variance is right. You might say, no, I don't want the variance when there is no last year, which you can do that with a simple if statement. Here I can say that if period last year is blank, and you can check that with a function called is blank, or you can say equal to blank or something like that. It's blank and return blank. Otherwise, do this. Alternatively, you can say that if not is blank of that, then do this, right? There are different ways of writing different things in DAX. I'm just adding some indentation here to make it more readable. So what I'm saying that if it is blank, don't give me this variance, otherwise give me the variance. And you can see here that I get the variance only if there is a same period last year for that. Now I can use this also to calculate the percentage, and that would be another simple expression, just this divided by that. So I can say sales year-over-year percentage. Now to calculate the percentage, you just need to divide the variance by the sales last year, right? Now, however, we don't usually do divide like this. I mean, it is fine to do it, but if this value is blank, then you get an error, right? Like like this. Let me bring it over here. In some scenarios, you might not get it if you don't get divide by 0 or something like that. Now, in this case, because I've already handled these not to be showing values if it is blank over there, I don't get that error. But if this had a value, this didn't have a value, then I would get infinity as an error. So because of that, usually we use a divide function. And the way that you use divide function is just like this, divide this by that. Here you can see that what happens if it is divided by 0. What is the alternate result? You might say, I want -1, I want, let's say, not applicable, or whatever you want to type. Or if you leave it default, this will return blank in case it is divided by 0. So if you ever expect this value that you are dividing by to become 0, it's a good idea to use divide function. Okay. So this is my percentage value. I'm just configuring it as percentage, and you can see here that easily I got a percentage of year-over-year calculation. You can show these in line chart, column chart, in any other types of charts as well, right? So as you can see, we are just adding more intelligence to this solution with adding more calculations. We had year-to-date calculations. Now we have this year versus last year, like a growth year-over-year percentage and things like that. Now you can extend this with even other periods. This is at the moment year-over-year. What if I want to do like month over month? I want to compare this month versus last month. How can I do that? Same period last year function is only going like the same period, but a year ago. It doesn't go 1 month back. You can use other functions. One of these functions is parallel period. So that would be another measure. Let's say this is sales last month. A parallel period is a function that you use it like this. It's always a good idea to learn how to use this. So it needs 3 parameters. The first one is a date column. Remember this S beside it, it means a date column. Then the second one, number of intervals, and then last one, interval itself. So my date column is the date itself, right? Of intervals. Now, if you want to go back in your periods, you should use negative value. If you want to go forth, you should use positive. If I'm going like 1 month back, this should be -1. And then where I define the interval, that would be the third parameter. So I can say month, quarter, year. The difference of this with the same period last year is that this is not only yearly, this can be done in 2 other intervals as well. Altogether, parallel period of this date, whatever date it is, May 2006, for example, give me 1 month before that, April 2006. But again, this function is not returning one single value. So if it is like May 2006, if I use this approach and find out that the month before that is April 2006, I want to use that to filter my sales data, because this is returning like a table. So I would use that inside a calculate function. These are tabular functions, parallel period, same period last year. These are tabular functions. You need to use them inside another function as a filter. And that is what I'm going to do, right? So I'm saying that calculate the sales. Now my filter is this parallel period, right? Just moving this a little bit further. Yeah, here it is. So here you can see that calculate sales for that parallel period. If you compare this with the sales same period last year, the difference is that I replaced that same period last year expression that used to be here now with parallel period. And I'm saying that go 1 month back instead of going like the same period last year. That is different, right? So now using this, I can add it to my table. I just remove a couple of these expressions to make a little bit of space. Let's say remove these year to date, and I'll bring that sales last month. And you can see that for every given month, like October 2005, this value is the value coming from September 2005, or in September 2005, this is coming from August 2005. And now that I have this and that, similar to what you have seen on a year-over-year variance, I can do like month-over-month variance, and then month-over-month growth percentage and things like that as well, right? So all of that is possible because now I've used this. Now you might say that, okay, like parallel period can also go 1 year back. What would be the difference of that using it like that instead of like same period last year? The thing is that if you use parallel period to go 1 year back, and if you are in a month level, it goes to the entire year last year, versus same period last year is going to like exactly the same period, but last year. If you want exactly the same behavior of that, you need to use like parallel period with a little bit difference with like minus 12 months, which would work again in this filter context. But as soon as you bring like quarter in it, as soon as you go to the day level and things like that, it would behave differently. So they look like they are similar to each other, and parallel period has more into it, but it's not. Same period last year has its own benefits. It's more dynamic in its nature. Doesn't matter if I go to the month level, day level, week level, or quarter level, it works just fine dynamically, but it is only limited to go 1 year back. Parallel period, on the other hand side, is not dynamic. You have to define the period, but it will go to more than like 1 year. You can go 1 month back, quarter back. You can do like 2 months back, 3 months back, or fourth if you have those information like in the future and see compare this with what's coming, right? There is also another function that helps in this calculation, and that is dateadd. I'll show you that to calculate something different. Any of these expressions that I'm writing for you, they can be written in many other different ways as well. One of the beauties of DAX is that you can write one expression in many different ways. Because it's such a flexible language, you combine functions together in totally different way. But on the other hand side, this can be also a little bit confusing, because not all of those methods are returning exactly the same output. You have to try different filter contexts to see how it is working. So I'm going to show you like one other expression here, and then we'll check if there's any questions. So I'm going to say, give me the sales like for yesterday. Now we do have a function for like previous day, next day, previous month, next month, previous year, next year, right? We do have those, but I'm showing you like a more flexible option that you can customize it as well. And that is with dateadd function. Now dateadd function is kind of similar to parallel period in terms of choosing the intervals. You see here that I have also interval. One of the advantages is that here I also have the day interval. In parallel period, I didn't have that. So my inputs are the date field. This would be date. Another input, the number of intervals. I want to go, let's say -1, and I choose day. Again, dateadd is not returning one single value. Even if it is 1 day, it is still in a table format. So you have to use it inside a calculate expression if you want to calculate the sales for it, right? So I can say calculate sales for this period. As you can see, most of our expressions is like calculate this value. We only change the filter. That is how mostly you do a lot of your DAX expressions by changing the filter, right? And now if I bring it over here, this should give me the sales yesterday. Now, This would be a little bit tricky here because we are not at the day level in our visual. The filter context is at month level. So this value that you see is slightly like confusing what this means. You will get the proper result of that when you bring the day into your visual. Let me just do that. Right. And day not like this. Let's say day as don't summarize. And now you can see that, right? For others, you won't see the values until you get to a specific point. But for this, you see that for every day, this compares it with the previous day. And then you can have day over day calculations and things like this. So it's all matter of the context, how you use it. Okay, so just a wrap up before getting to the questions. DAX calculations and time intelligence is based on a date table. This date table can be the date table that you create yourself, custom date table like what you have seen here. And if you use that, make sure you mark this date table as a date table. I think I forgot to mention you that. You click here and you say mark it as a date table. And you use your expression just like that. Another thing is you use the default date table. If you use that, make sure you use the dot date for your expression. Then we have a lot of time intelligence functions. You have seen some of these year-to-date functions, same period last year, dateadd, and parallel period that can be helpful in these calculations. I just bring this last slide and see if there is any question. So everything that I explained to you, I have written a blog about it. It's free, available in dateadd website. Go and check it out. I have sometimes videos accompanying that blogs as well, and you can go to your YouTube channel to check it out. And I have also a DAX video course that explains that in details and much more information in that. So I'm available if there is any questions.
Yes, we do. Fantastic session as usual, Reza. Love it.
Thank you.
I always learn so much every time you present your content. So easy to consume. We do have a question from, it says, hello from Costa Rica. What is the difference between the parallel period and dateadd?
So there are a bunch of differences, like one of them you already seen. The dateadd also gives intervals of the day. Like, for example, if I want to go like 5 days ago, I cannot use parallel period for that. Another difference is that parallel period is kind of, sorry, it's kind of dynamic, similar to same period last year. Depends on the context that you use. It goes like back like that. So dateadd is kind of a dynamic versus parallel period is static. I have written a full blog post and a video exactly comparing same period last year, dateadd, and parallel period. So go and check it out on dateadd website.
Excellent. So the person from Costa Rica, I hope that answered your questions. We do have another question. How do I calculate total quarter to date for fiscal quarter where the fiscal year starts in August, thus quarter 2 spans 2 years? Thanks. And that's from
So in scenarios that or quarters are different from calendar quarters, like for example, it starts from August rather than starting from July, we can't use that total QTD or date QTD really good enough. Your alternate option would be to calculate that period yourself. I would always suggest to have like those fiscal columns in your date table, because if you have it over there, like this example, if I have this over here, I already have my quarter start. I already have my year start. I already have all of those. So I just bring the fiscal quarter in my filter context and everything works perfectly fine. However, if I want to do that using DAX expressions, then for that, you need to calculate it a little bit differently. You need to first find out what is the start of this quarter, considering that August is like the first of your fiscal year. use some calculations, some functions to find it, some date time functions in DAX to find it, and then calculate the sales from start of that quarter to that value.
Okay, sounds good. Let's see if we have a follow-up question there. No. Bravo, Reza. Great content as always. Thank you. That's Cecilia from South Florida. So
great.
Thanks, Cecilia. Awesome. There are no more questions right now, Reza. I think you did such a great job with explaining all of this.
Awesome.
Yeah.
Thank you. And I'll might do another session later on, like extending a little bit of these time intelligence functions. But if you like this, just let me know through our blogs and everywhere. We'll schedule another session later. And thanks, Kelly and Deepak, for the opportunity.
Thanks so much, Reza. We enjoy your talk so much. Looking forward to your next webinar.